Dear students, me, your Madam Lakshmi Hebbar here. Well, we come to the end of second chapter, reactions of aromatic hydrocarbons. In this last session, let us study about some new types of aromatic compounds. Those are biphenyls and alkynyl benzenes. For the biphenyls, we have to discuss the preparation by Ullmann reaction. And in this alkynyl benzenes, example stilbene, I have to study the preparation and geometrical isomers, that is cis-trans isomers of stilbene. Now let us take up the first compound, that is biphenyl, which is also known as diphenyl. Now this biphenyl is having a structural formula given here. It contains two phenyl rings joined by a single bond called as pivot bond, and each ring carbon atoms are numbered separately. In this ring it is numbered from 1 to 6, and in this ring the carbon atoms are numbered as 1 dash to 6 dash. This biphenyl is a pleasant, colorless, water insoluble crystalline compound. And now let us discuss about the preparation of biphenyl by Ullmann coupling reaction. This reaction is named after the scientist Fritz Ullmann, who carried out this method of preparation of biphenyl. Before that, let us know what is meant by coupling reaction. Coupling reaction is organic reaction that involve the joining of two chemical species, usually with the help of a metal catalyst. If the two chemical species involved in the reaction are same, then it is called as homo-coupling reaction. If they are of different species, then it is called as hetero or cross-coupling reaction. Now coming to the Ullmann coupling reaction, which is used for the preparation of biphenyl. It is a coupling reaction between aryl halides in the presence of excess of metallic copper. So copper is catalyst here to form biphenyl. It is carried out under relatively high temperature, more than 200 degrees Celsius. Here this is aryl halide, that is iodobenzene. Two molecules of iodobenzene is added to the copper at high temperature more than 200 degrees Celsius. It gives a product biphenyl along with copper iodide. Now this reaction mechanism involves series of oxidative addition and reductive elimination reactions. So if you go through the mechanism briefly, then you will understand what is oxidative addition and reductive elimination. Here you can find a molecule of iodobenzene which reacts with the copper, gives a compound C6H5Cui. It is called as oxidative addition because copper undergoes oxidation from atomic state to plus state, and it is added by aryl iodide, that is iodobenzene. That is why it is called as oxidative addition reaction. Again it reacts with the copper metal to give a species called as active copper species, where copper is in the +1 state. Now again another oxidative addition takes place here with another molecule of iodobenzene to give a compound of copper which has the structure given here. Copper is +1 state, and in the product it is in the +3 state. That is why it is called as oxidative addition, where iodobenzene is added. Now this compound is again undergoing reductive elimination. This is elimination where copper iodide is eliminated, in which copper is in the +1 state, but in this it is +3 state. So it is reduction, and it is eliminating copper iodide. So it is called as reductive elimination to produce required product biphenyl, in which a new carbon-carbon bond is formed. This mechanism you need not worry about, only for understanding purpose. So remember only this equation. Now this reaction is preferably carried out in the solvent called dimethyl formamide, simply DMFA. Aryl halides although give somewhat good yield, but if you carry out the Ullmann reaction with the aryl chlorides or aryl bromides, the reaction will fail unless an electron withdrawing substituent is present in the position ortho or para to the halogen. Very good example you can give for this is orthonitrochlorobenzene, where chloro group is having electron withdrawing nitro group on the ortho position. So 2 molecules of this in the presence of copper bronze alloy at 200 degrees Celsius for 180 minutes in presence of sand, it gives biphenyl derivative, that is 2,2-dinitro-biphenyl along with the copper chloride. Again you can observe here the yield is less, only 52%. So it can be noted that Ullmann reaction is known to give relatively low yields. That is why palladium catalyzed coupling reaction, for example Heck reaction, is preferred over the Ullmann coupling reaction. And also one more disadvantage is the Ullmann reaction is carried out under the quite harsh conditions, that is at high temperature. That is why this Ullmann reaction is not so easy to carry out to produce diphenyl. Now if you want to know about the uses of biphenyl, it is an important starting material for the production of polychlorinated biphenyls known as PCBs, which were widely used as dielectric fluids and also heat transfer agents. And biphenyl is also an intermediate for the production of many other organic compounds such as emulsifiers, optical brighteners, plastics and crop protection products, you can say pesticides. So that is all about the biphenyl. Now let us pass on to next type of organic compound, alkenyl benzenes. So here they have given the example stilbene, which you have to study. The stilbene is an alkene having formula C6H5, CH double bond CH, C6H5. That is nothing but the derivative of ethene. Ethene is CH2 double bond CH2, where one of the hydrogen atom on each carbon atom is substituted by phenyl ring. So it may be named in the IUPAC as 1,2-diphenyl ethene. Since it contains carbon-carbon double bond, it exists in two geometrical isomeric forms. First one is trans 1,2-diphenyl ethene, which is also called as E-stilbene or trans stilbene. Second one is cis isomer, that is cis 1,2-diphenyl ethene, known as Z-stilbene or simply cis stilbene. Now trans 1,2-diphenyl ethene or trans stilbene is having this structure. You know, trans isomer will have similar groups are on the opposite sides of the double bond. So here phenyl groups are on the opposite side of this carbon-carbon double bond. That is why it is trans stilbene. It is found to be stable because there is no steric hindrance between these two phenyl rings. Its melting point is 124 degrees Celsius. And for cis stilbene, the structure will be like this, where both of the phenyl rings are on the same side of the carbon-carbon double bond. Hence there will be a steric hindrance and the compound found to be relatively unstable than the trans isomer. And the melting point of this is 145 degrees Celsius. Now for this stilbene you have to discuss the preparation. Here you can use any one method, but I selected Wittig's reaction for the preparation of stilbene because of its simplicity. Now by this method we can prepare both cis and trans. Although trans is produced in the major quantity, we know that Wittig's reaction is a reaction between an ylate, phosphorus ylate, and a carbonyl compound, maybe aldehyde or ketone. So in this preparation of stilbene, we use this ylide, which is also called as Wittig reagent, which is having the structure given here, that is triphenyl benzyl phosphonium ylide, where there is a double bond between carbon atom and the phosphorus, and the carbonyl compound used is benzaldehyde here. In this Wittig reaction, we have to prepare Wittig reagent first from the benzyl triphenyl phosphonium chloride by treating with concentrated sodium hydroxide in the presence of methylene dichloride. So this is benzyl triphenyl phosphonium chloride treated with the concentrated sodium hydroxide in the presence of methylene dichloride. It gives this product that is called as ylate, which we had shown here. Only difference you can observe is the double bond is present here. Instead of that, here it contains one single bond and the negative and positive charge are separately written. Carbon atom has got negative charge and phosphorus has got positive charge because of more electropositivity of phosphorus, and this type of compound is called as ylate. Now this is made to react with benzaldehyde, where the negative charge present on the carbon atom will attack on the carbonyl carbon atom, which is partially positive due to the polarity of this CO bond. By that, double bond electrons are moving towards the oxygen. So it goes on by involving intermediate, which we already studied in the first sem clearly, to give trans stilbene as a major product and cis stilbene as a minor product, along with removal of triphenyl phosphorus oxide. Now you can just imagine the reaction here. This is ylate and this is benzaldehyde, and if you remove this portion which is represented by red color, then you join this carbon atom of benzyl group to the carbon atom of this benzaldehyde by double bond, you will obtain this stilbene either in the trans form or in the cis form. So it is easy if you write this two reagents like this to give the product. Now uses of stilbene, it is used in the manufacture of dyes and optical brighteners, and also as phosphor and a scintillator. And many stilbene derivatives called as stilbenoids are present in plants naturally. For example, resveratrol and pterostilbene. Stilbene derivatives, especially trans stilbenes, have estrogenic activity. So it is used in making non-steroidal synthetic estrogens such as diethyl silvestrol and diinestrol. Now here you have some reference and some internet sources also I had used for the reference. With this we come to the end of the session and also the chapter, and in the next session we will start with a new chapter, that is cycloalkanes. So for the two chapters I had given multiple choice questions, and by referring that, if you study the topics, you will understand better, I hope.